Started. Okay, I wanted to go back one slide here. Okay, so this is the standard physicist conjecture about the asymptotic expansion for the minimum logarithmic energy. So minimum logarithmic energy playing an important role in the so-called Snell conjecture, and it consists of an n squared term, an n log n term, an n term, and then followed by the log term, which was the essential term for Smale's conjecture, getting energy configurations that are within this log term. But there are some questions about whether there is something between n and log n, and some numerical experiments that were due to Rob Wormersley seem to suggest that there might be a term like the square root of n log n. It's based on very careful computations. As I remarked earlier, we never know whether we're at an absolute minimum or not. And the coefficient e that he gets here, in fact, is rather small. So the coefficient that comes out numerically is a rather small number. But on the other hand, we have looked at S energies when S is large and found that there is a term, and the term is of the following type. It's n to the power 1 plus S quantity over 2 times log n that appears in the asymptotic expansion for the energy. So this is for S large. We don't know whether it occurs for the logarithmic energy, but this is what we are conjecturing in hopes that it invites some new research in terms of what is whether there is a term that was missing, and perhaps due to the scar arrangement. And we're trying to come up with some physical justification, working with Florian Thiel, Doug, and Rob Wormersley, a physical interpretation of these scars that would give rise to the square root of n log n, interpretation that utilizes this Reed-Shockley law that tells you how the energy density changes as you change the orientation between the lattices that are at one side or the other of the grain boundary. So thank you again. I'll stop.